observe as something quiet has slipped into our sky, and whether you meant to or not, you arrived at the moment this story needed you. You were drawn here for a reason, as if a subtle thread in the cosmos led you to this question. What are the odds that an object 7 miles wide, older than Earth, would follow a path so precise it brushes Mars' hides behind the sun and sweeps past our world as if studying us? What if such alignment isn't coincidence at all, but intention? Now let the noise fall away. Picture only a silent shape drifting past the edge of Mars, carrying secrets it will never speak aloud. Stay with me. Let's drift a little deeper. 3. I, Atlas, entered human awareness, without urgency, recognized first as nothing more than a faint point of motion drifting across the sensitive field of the Atlas system in Chile. Automated algorithms nearly dismissed it as routine data, another small signature among thousands collected each night. Yet even in its quiet arrival, something about the object felt older than the coordinates attached to it, older than the sky that framed its passage. In moments like these, silence becomes a form of thought, as if the universe pauses long enough for us to notice what is moving toward us. The object appeared dim, its magnitude low enough to be nearly lost in the noise, and its motion steady but slow, showing none of the behaviours that mark active comets or passing debris. Most detections like this dissolve into the catalogue without deeper meaning, but this one drew attention not through spectacle, but through the soft discipline of repeated measurement. The more astronomers watched, the more the numbers refused to settle into familiar shapes. Sometimes wonder begins not with revelation, but with the gentle refusal of data to behave as expected. Within days, observatories around the world joined the effort to refine the orbit. Tenerife added precision. Arizona contributed astrometric threads. By July 6th, the pattern emerged clearly: eccentricity greater than 1, a trajectory not tied to our sun, not cyclical, not bound. It was interstellar. Only the third confirmed traveller of its kind, carrying a path written far beyond the cradle of our system. The realization spread quietly, not with alarm, but with the subtle weight of perspective. Somewhere beyond our reach, something ancient still moves. Size estimates soon followed, drawn from photometric modelling and rotational cues. 7 miles across, vast compared to Oumuamua and Borisov, our previous visitors. A body that large should have carried a luminous signature dust-shedding sublimation fragments, illuminated by the sun. But 3i Atlas remained muted, darker than charcoal, reflecting only a small portion of the light that touched it. In that deep darkness lay a strange calm, the calm of something that has wandered for ages without needing to announce its presence. Silence is the universe thinking, and sometimes its thoughts are patient. Rotation studies revealed a steady 12-hour spin, suggesting a shape closer to a sphere than to a shard. Density estimates placed it in the realm of icy bodies, water organics and mineral traces bound together in a structure that looked natural, yet preserved in ways that defied the usual scars of interstellar travel. Radiation should have carved it, dust should have worn it down. But the surface remained pristine, almost untouched. In science, we learn to trust anomalies as invitations. They widen the frame through which we observe our place in the cosmos. Spectroscopy deepened the mystery. Water ice expected familiar, but with isotopic ratios that diverged from anything our solar system has ever formed. Deuterium levels pointed to stellar nurseries older than ours, perhaps enriched by generations of stars that lived and died before Earth existed. Alongside the ice complex, hydrocarbons revealed themselves in long ancient chains. They were not shaped by heat or by the turbulence of young planets. They were cold, forged, preserved, through epochs carried across a void where only endurance survives. Traveller. It's all right to not understand. More detailed observations revealed organic signatures that refused to fit neatly inside existing models. Methane, ethane, carbon. Rich polymers all present, yet not in proportions we associate with local formation. Even nitrogen isotopes bore patterns foreign to our region of the galaxy. These differences did not suggest something unnatural. Instead, they spoke of a lineage formed under a distant star shaped by conditions our world has never known. The scale of time embedded in these molecules reminds us that our species is young, our expectations narrow, our certainty fragile beneath the weight of cosmic history. Yet one detail stood apart: the absence of activity. As the object approached the sun, it did not brighten through outgassing. It did not produce cyanogen. It did not shed diatomic carbon, the usual signatures of a comet awakening under solar heat. Its surface remained still. Some astronomers suggested a hardened crust shaped by long exposure to interstellar radiation. Others proposed that its chemistry avoided the familiar pathways that produce early emissions. Both explanations were reasonable, yet neither dispelled the quiet sense that the object was withholding something, not intentionally, only naturally, like a story revealing itself slowly. If the surface had been altered by eons of cosmic exposure, perhaps a rigid shell now insulated the volatile interior. If its chemistry originated in a colder, quieter region of space, perhaps the usual gases simply did not form. These possibilities settled into the discussion with the gentle weight of realism. Still, the absence of expected behaviour left open a space, one where speculation and humility meet. When the universe offers a puzzle, it is rarely to unsettle us. More often, it is to remind us that even our best models are only approximations of truths larger than ourselves. The object's orbit added yet another layer of curiosity. A retrograde path inclined at 162 degrees, almost polar cutting through the solar plane in a direction that allowed continuous visibility from Earth. It never vanished for long behind the sun. It never slipped into regions where our instruments could not follow. The alignment was not perfect, yet it was strangely accommodating, as if circumstance had opened a narrow window of observation before closing again. Whether coincidence or something quieter, the effect was the same. We watched, and we remained able to watch. And so this opening chapter settles into its stillness. The object remains a faint point of moving light, carrying fragments of a story older than our species and quieter than our expectations. Its behaviour challenges our models, but not our sense of safety. Its silence feels less like secrecy and more like distance, the kind written by time, not intention. Tonight, as we sit beneath the sky that received it, we are reminded of something simple and steady. The unknown is not hostile. It is only vast, and in that vastness we are allowed to listen without fear. The trajectory of 3i Atlas began revealing itself through layers of refinement, each calculation adding quiet structure to a path that seemed almost too deliberate for chance. As astronomers reconstructed its inbound motion, they noticed how precisely it threaded through the solar system, slipping between planetary orbits with a grace that seemed more like choreography than randomness. Hyperbolic visitors can arrive from any angle, yet this one approached in a way that maximised visibility, crossing the ecliptic at a steep incline, while remaining within reach of ground-based and orbital instruments. Silence does not always mean absence. Sometimes it is alignment. Retrograde motion alone was not unusual, but the combination of inclination, timing and distance formed a pattern difficult to dismiss. The object's path mirrored simulations once used to model optimal reconnaissance trajectories, sequences designed to observe multiple worlds in a single pass. Even so, scientists resisted poetic interpretations, knowing how easily human minds impose meaning on coincidence. Yet the numbers remained. On October 3rd, Atlas would approach Mars at a distance close enough for high-resolution monitoring. The timing placed the planet in dawn, lighting a condition perfect for atmospheric contrast and reflective clarity. Coincidence perhaps, but a layered one. The next milestone arose from the predicted perihelion, October 29th, just beyond Earth's orbit, where sunlight would strike the surface with enough force to test the chemistry of any dormant material. Yet perihelion occurred on the far side of the sun, hidden from Earth's direct view. Only spacecraft at L1 and instruments around Mars would witness the moment. Listener, such timing felt like the universe arranging a veil thin enough for measurement, thick enough for mystery. In astronomy, we often watch through shadows, trusting what light remains to guide us. After perihelion, the object's outbound arc brought it near Earth on December 19th. Not dangerously near far enough to avoid perturbation, close enough for the James Webb Space Telescope and the Vera Rubin Observatory to examine it in detail. The geometry of the encounter favoured northern hemisphere visibility, allowing a long window of uninterrupted study. Statistical models place the odds of such favourable alignment at less than a few percent, not impossible, but undeniably rare. The universe never promises intention, yet it sometimes allows patterns to unfold that stir the imagination. The final encounter lay far ahead in March 2026, when 3i Atlas would pass within 33 million miles of Jupiter. To some, this was the most compelling segment of the trajectory. Jupiter's magnetosphere, the largest continuous structure in the solar system, would envelop the object, allowing instruments aboard Juno to study its interaction with charged particles and magnetic fields. The encounter would also allow for the possibility of dust capture, as the giant planet's magnetotail could sweep particles shed by the interstellar visitor and hold them long enough for analysis. A natural event, yes, but one that seemed to echo the logic of mission design. As astronomers layered each segment of the path into global simulations, the combined probability dropped into ranges that demanded careful thought. One chance in 20,000, according to some estimates, a number low enough to spark discussion, yet high enough to remain safely within the domain of cosmic coincidence. Astronomy thrives on this tension. The sky teaches us that improbability is not impossibility. Rare events scatter across the cosmos without purpose, simply because vastness creates room for every outcome. Still, the trajectory of 3i Atlas became a subject of conversation far beyond orbital mechanics. Some researchers noted how the path avoided close encounters with the outer giants, Saturn, Uranus, Neptune minimizing gravitational disruption that could have destabilized its precision. Others observed that its retrograde angle maximized the object's passage through incoming solar wind offering rich data on particle distribution. These features echoed mission parameters humans might design, though the resemblance alone proved nothing. Scientific rigor required the community to treat such parallels with caution. Theories anchor themselves in evidence, not intuition. Yet intuition often nudges the mind toward questions we might otherwise overlook. Silence is the universe thinking, and unanswered questions are its steady breath. The public conversation grew as details emerged. Questions arose about whether interstellar visitors could naturally follow such complex paths. Meteoric fragments occasionally pass near multiple planets. Comets drift through gravitational fields that subtly shape their routes. But Atlas differed. Its path was smooth, uninterrupted by detectable non-gravitational accelerations, and aligned in ways that seemed optimized for observation rather than randomness. The suggestion of design surfaced not from certainty, but from the human instinct to interpret patterns. The scientific community acknowledged the curiosity while emphasizing restraint. Patterns alone do not define purpose, yet the dialogue carried value. It encouraged deeper investigation, leading astronomers to re-examine data from Oumuamua and Borisov, searching for similarities or signs of overlooked structure. While no direct parallels emerged, the exercise sharpened models, expanded simulations, and deepened understanding of interstellar population dynamics. Atlas became not just an object of study, but a lens, a way of refining humanity's methods for interpreting faint signals from deep space. In questioning the object, researchers also questioned their own frameworks, an essential step in the quiet evolution of scientific thought. Precision tracking continued through late summer, revealing subtle gravitational interactions that helped confirm the object's mass and density. As its predicted rendezvous points approached, telescopes prepared for coordinated global campaigns. Instruments were calibrated, observation windows were optimized. Agencies collaborated with a calm urgency, not out of fear, but in recognition of the rarity of such an opportunity. The object moved without haste, following a path written long before human eyes evolved to witness it. And as it drifted inward, astronomers felt again the humbling truth that our system is not a closed island, but a crossroads. No matter how the object behaved naturally unusually, or with unexpected calm, it reminded us of something simple and profound. We do not control what enters the sky. We only choose how to observe, how to interpret, how to remain open without surrendering to speculation. Atlas's path continued to unfold with mathematical elegance, whether born of chance or shaped by forces we do not yet comprehend. It taught patience, inviting us to follow its motion, without rushing toward conclusions. In its long arc there was room for curiosity, skepticism, and quiet awe to coexist. As autumn approached and the object neared the inner regions of the solar system, the first true tests awaited. Solar heating would reveal whether the surface remained dormant or awakened in subtle emissions. The Mars encounter would show whether dust or gas emerged under distant observation. And perihelion, shielded from Earth but not from our instruments, would offer the clearest moment for truth to surface. Yet beneath every calculation lay a deeper acceptance. Not every mystery resolves cleanly, and not every answer arrives on schedule. The sky does not hurry. It simply moves, and we listen. The composition of 3i Atlas began revealing itself through spectra along patient lines of reflected light, carrying information older than any record humanity has written. When the first data arrived from the NASA Infrared Telescope facility, astronomers found the unmistakable signature of water ice, yet its isotopic fingerprint was unlike anything native to our solar system. The deuterium to hydrogen ratio placed its origin in a stellar nursery far removed from our own. In that discovery, the object's identity shifted from a visitor to a relic, a preserved fragment of a world that formed and faded long before Earth emerged from dust. This pristine water ice carried a story uninterrupted by heat pressure, or resurfacing a chemical memory that had drifted through interstellar darkness for perhaps billions of years. Most comets in our system bear scars from repeated cycles of sublimation and regrowth. Their histories are rewritten each time they approach the Sun. But Atlas showed no such erosion. Its ice had never melted, never reorganized, never forgotten its beginning. In that stillness, astronomers sensed a rare opportunity, a chance to study matter that predates our oceans, our continents, and the fragile biology resting between them. Gemini South later uncovered additional complexity. The spectra revealed methane, ethane, and traces of long-chain hydrocarbons molecules that form in ultra-cold environments, where chemistry moves at the pace of drifting dust. These organics, preserved in delicate balance, suggested an origin in a disk rich with carbon and oxygen, possibly around a star older than our Sun. Listen to such chemistry reminds us of our smallness. Life on Earth is only one arrangement of matter. The galaxy contains countless ways for atoms to bind, release, and evolve under conditions we may never witness directly. The more researchers examined the data, the clearer it became that this object retained nearly all of its primordial composition. No evidence of high-temperature minerals appeared in the spectra. No trace signatures of materials forged near a star's inner regions. Unlike comets in our system, which contain mixed histories, Atlas seemed to have formed entirely in cold outer space, far beyond the warmth of its parent star. It was not a migrant of many environments, but the product of a single stable place then violently ejected, set adrift into an endless night. Even the nitrogen isotopes carried hints of distant astrophysical processes. Ratios differed from every known comet in our system, pointing not just to a foreign birthplace, but to a foreign chemical lineage shaped by nucleosynthesis distinct from our Sun's ancestry. To astronomers, this was more than an anomaly, it was a message written in chemistry. Stars are storytellers, and their children carry fragments of those stories long after the stars themselves have aged or vanished. Atlas arrived as a messenger of such a story, but one without language, delivering only Ratio's lines and subtle spectral slopes. As August progressed, more telescopes joined the effort to decode the object's structure. One puzzle stood out despite its abundance of volatile ices. Atlas remained inert. At distances where comets begin to breathe, shedding gas, building comae tracing their presence, with visible emission lines, this visitor stayed silent. The absence of cyanogen and diatomic carbon puzzled specialists. Those molecules appear early in the activation of typical comets, yet here nothing emerged. Some theorized a hardened crust created by aeons of cosmic radiation. Others suspected the organics themselves might resist breakdown into simpler gases. Theories multiplied, yet each carried gaps. A crust could delay activation, but total absence suggested something more fundamental. Perhaps the chemistry of Atlas simply followed pathways unfamiliar to us. Interstellar environments, after all, forge structures under conditions impossible to replicate in laboratories on Earth. Over millions of years, cosmic rays can break and recombine molecules into forms with unusual resilience. These shapes survive because they require nothing and resist everything. In that possibility, a kind of elegance emerged, a body shaped by time alone unchanged. because time had already done all it intended to do. Astronomers also considered more speculative explanations. If the object had travelled through dense regions of the interstellar medium, dust impacts could have embedded a protective mantle several centimetres thick. Such a layer would conceal internal ices, preventing sublimation until intense solar heating forced a breach. But as Atlas approached 2 astronomical units, still no signature appeared. The object held its composure like a stone suspended in slow motion, revealing nothing beyond reflected light. Silence is the universe thinking, and sometimes its thoughts resist our methods of inquiry. Another possibility arose from isotopic anomalies. Perhaps the organic compounds did not decompose into familiar diatomic molecules when heated. If complex chains remained stable under solar warming, the expected early emissions simply would not form. No cyanogen, no carbon dimer. Instead, sublimation might produce heavier fragments too diffuse or too faint for detection with current instruments. Models of such behaviour were purely theoretical, yet the object itself offered evidence that nature's possibilities exceed the boundaries of our predictions. Despite the persistent quiet, astronomers found themselves captivated, not by what Atlas displayed, but by what it withheld. The absence of activity did not diminish curiosity, it sharpened it. Most discoveries announced themselves through change, brightness, heat distortion. Atlas announced itself through constancy, through the refusal to transform, through the commitment to remain exactly as it had been since its ejection from its ancestral system. In that unwavering silence lay a beauty that shook even seasoned researchers, an ancient calm drifting through a system defined by motion. The implications extended beyond composition. If Atlas truly preserved its internal structure without alteration, then studying it offered a glimpse into conditions present before Earth existed. Its ice could reveal the metallicity of its parent star. Its organics could map chemical pathways in distant molecular clouds. Even its lack of activation could teach us the limits of our cometry models. In that sense, the object functioned less as a mystery and more as a teacher, one guiding us toward humility in the face of cosmic diversity. As the final weeks of August drew near, the scientific community prepared for the next phase of observation, knowing that solar proximity would soon force the object to reveal more of its nature. Whether it awakened slowly, erupted briefly, or remained silent altogether, its behaviour would refine theories and challenge assumptions. Yet beneath the anticipation lingered a steadier truth. Not every story reveals itself fully. Some allow only fragments, leaving the rest to be understood through patience. And as Atlas continued inward, drifting through sunlight it had never felt. Before the quiet reminded us that uncertainty is not failure, it is simply the first step toward understanding. As the weeks passed, scientists turned their attention from the object's composition to its path, an arc so improbable that it required careful study not for its potential danger, but for the quiet sophistication embedded within it. 3i Atlas approached the solar system on a steep retrograde incline, cutting through the planetary plane like a thread drawn across fabric. Retrograde motion was expected from interstellar objects, but the angle 162 degrees created a geometry that kept Atlas visible for nearly its entire inward journey. This alone felt unusual. Most visitors vanish behind the sun for long periods. Atlas did not. Its presence lingered. When astronomers projected the object's future trajectory, they noticed a sequence of alignments that read less like randomness and more like celestial choreography. The first major encounter would occur on October 3rd, close past by Mars at a distance that allowed multiple orbiters to observe the visitor with unexpected clarity. The timing placed the red planet in dawn illumination, its shadow geometry ideal for contrast imaging. Even among natural coincidences, the alignment felt precise, almost curated. Yet science demanded caution. Coincidence is generous in a universe with this much space and time. The perihelion on October 29th drew even more attention. At 136 astronomical units, Atlas would experience its peak solar heating, revealing whether its silent surface would finally stir, and yet the moment would occur on the far side of the Sun from Earth, hidden from ground-based telescopes shielded by the overwhelming brightness of the solar disk. Only spacecraft positioned at L1 or instruments orbiting Mars would have an unobstructed view. The geometry felt like a natural eclipse of knowledge, a pause in observation not chosen by us, but offered by the sky itself. December the 19th marked the next point of interest, a safe but favourable approach to Earth. At 170 million miles, Atlas would be close enough for James Webb and the Vera Rubin Observatory to watch in exquisite detail. The angle made infrared analysis ideal. The outbound cooling phase would allow telescopes to measure subtle changes in composition after solar exposure. These opportunities did not guarantee answers, but they offered windows, brief, delicate, and scientifically precious. The more closely astronomers studied the timeline, the more they felt the steady pull of improbability humming beneath the numbers. The most dramatic alignment awaited in March 2026, when the object would pass through Jupiter's magnetosphere. The planet's magnetic field extends millions of miles, dwarfing even the Sun's influence in some regions. As Atlas drifted through this charged environment, instruments aboard Juno would have a chance to study how the interstellar body interacted with plasma dust and radiation. Some models suggested the possibility that dust shed from Atlas might be trapped in Jupiter's magnetotail, allowing for indirect sampling. Whether or not such capture occurred, the geometry itself was remarkable, another moment of observation that seemed to materialize at exactly the right time. Statistical analysis soon began. Monte Carlo simulations explored millions of possible arrival vectors and orbital inclinations, calculating how often an interstellar object would naturally pass near multiple planets in such clean succession. The estimates varied, but one figure appeared consistently, a probability near 1 in 20,000. Not possible, not supernatural, but rare enough to create space for reflection. Silence is the universe thinking, and sometimes it thinks in patterns that tug gently at human intuition. Yet scientists reminded themselves that rarity alone is not evidence. Improbable events unfold every day within a cosmos of unthinkable scale. As debate unfolded, attention turned toward the object's inbound velocity, high even for interstellar standards. At 33 kilometers per second relative to the Sun, Atlas moved faster than expected for natural ejection from nearby stellar systems. Some astronomers suggested it originated from a more distant region of the galaxy, launched by gravitational interactions long forgotten. Others considered stellar encounters, dense cluster dynamics, or ancient scattering events as potential explanations. Speed alone could not point toward artificial origin, but it added another thread to the tapestry of questions surrounding the visitor. The conversation occasionally drifted into speculation, exploring scenarios where such a trajectory might serve observational goals. A retrograde orbit maximizes encounters with solar wind particles. A polar inclination reduces time spent hidden behind the Sun. Sequential planetary flybys offer diverse gravitational environments. To human mission planners, these patterns resemble deliberate design. But resemblance does not equal intent. The scientific community held tightly to restraint, acknowledging the curiosity while maintaining the discipline necessary to avoid premature conclusions. The more the object resisted classification, the more astronomers revisited earlier interstellar visitors. Oumuamua offered lessons in uncertainty, anomalous acceleration, no coma, unusual shape. Borisov offered clarity, a more conventional comet exhibiting expected behaviour. 3I Atlas seemed to exist somewhere between them, borrowing elements from both, but never fully aligning with either category. Comparison deepened understanding without resolving ambiguity. In science, meaning often arises not from answers, but from the refinement of questions. Atlas expanded the domain of possibility. As autumn approached, preparations intensified. Telescope time was allocated across continents. Software pipelines were optimized for rapid data ingestion. Spacecraft teams rehearsed observation sequences. The community understood that opportunities like this were rare. Each moment required precision. Yet beneath the technical planning lay a quieter awareness, a sense that something vast was unfolding, something indifferent to human interpretation. The object moved without urgency, following a path shaped long before human consciousness tried to measure it. The closer Atlas came, the more its motion inspired reflection. Interstellar objects remind us that our solar system is not a sealed chamber, but a permeable space open to visitors from histories we will never fully reconstruct. Whether natural or unusual, Atlas carried with it a record of time and chemistry beyond our own. Its path asked us to watch without assuming, to consider improbable alignments, without surrendering to fantasy, to accept that the universe holds room for mystery without requiring explanation. And so, the stage was set. Mars awaited its dawn encounter. The sun prepared its shielded moment. Earth would soon take its turn as an observer. Jupiter loomed in the future like a great magnetic lantern. Through all these steps, 3i Atlas continued onward, steady, silent, untroubled. Its journey reminded us of something simple and steady. The cosmos does not move for our benefit, yet it allows us to witness, to study, and to wonder. The unknown does not demand fear. It asks only for attention, and for the humility to learn from what passes briefly through our sky. The scientific community entered autumn with a sense of quiet anticipation. 3i Atlas had remained unusually calm as it drifted inward, defying expectations of early activity. Ground-based telescopes watched the faint object move across the sky with the steadiness of a metronome, its light curve unchanged, its presence silent. Comets approaching the sun typically announce themselves with growing halos, dust eruptions, or faint chemical signatures. Yet Atlas preserved its stillness as if the warmth had not reached it at all. Silence in this context became its defining feature. This lack of activity did not signify emptiness. It suggested resilience. If the surface had been sculpted by millions of years of cosmic radiation, a hardened shell could have formed thick enough to shield internal ices from sunlight. Such crusts appear in long-period comets, but rarely with such persistence. Models attempted to reproduce the behaviour, and while some matched the early measurements, none fully explained the absence of common species like cyanogen or diatomic carbon. These gases should have appeared by now even in minimal quantities. Their absence deepened the riddle. Astronomers expanded their search to different wavelengths. Infrared scans looked for faint thermal changes. Ultraviolet instruments probed for emissions invisible in optical bands. Radio telescopes listened for rotational modulation or unusual scattering patterns. Nothing emerged. The object remained a study in restraint, offering only reflected sunlight, refusing to produce the simplest clues. Some researchers found this frustrating. Others found it beautiful, a reminder that cosmic phenomena do not exist to satisfy our timelines. Theories shifted toward the object's interstellar journey. Perhaps its long exposure to galactic radiation had fundamentally altered its surface chemistry, creating molecular bonds difficult to break. In such a case, sublimation would begin only when solar heating reached levels far beyond typical activation thresholds. The idea aligned with the object's age and isotopic differences, suggesting its materials were shaped under conditions our solar system no longer remembers. The closer scientists looked, the more Atlas resembled a preserved chapter of galactic history rather than a comet in transition. Yet even this hypothesis carried uncertainties. Interstellar erosion tends to reduce volatile content, not protect it. Dust grains strip surfaces. Radiation fractures molecular structure. Over time, such processes weaken rather than strengthen outer layers. But Atlas appeared almost untouched. This contradiction invited reflection. Perhaps some bodies leave their systems under conditions that preserve them uniquely, or perhaps our understanding of long-duration interstellar chemistry remains incomplete. The cosmos often reveals the limits of our assumptions, one quiet anomaly at a time. Attention soon turned to the upcoming Mars encounter. The flyby presented a rare opportunity to observe Atlas under sunlight, from multiple vantage point orbiters above the Martian sky rovers beneath its thin atmosphere, and Earth-based telescopes tracking from millions of miles away. If the object emitted even the faintest gas or dust, the red planet's instruments would capture it. And if it remained inert, that result would be equally meaningful. Mars would become a mirror through which the scientific community might finally glimpse a response. As mission teams prepared, discussions unfolded about the broader context of interstellar visitors. Oumuamua had challenged comet models through absence: no visible coma, no typical emissions. Borisov had affirmed cometary expectations through abundance. 3i Atlas occupied a third category: massive, ancient, and silent. This silence held weight. It suggested that interstellar objects represent a spectrum far wider than previously imagined. Some may awaken readily under stellar light, others may drift unchanged for billions of years. Regardless of outcome, researchers understood that Atlas was expanding the vocabulary of interstellar science. Its behavior encouraged new questions about how matter survives deep cosmic time, how chemical pathways evolve in frozen isolation, and how frequently massive bodies migrate between star systems. Each unanswered question carried its own quiet value, reminding observers that discovery often begins with the admission that we do not yet know enough. As the object continued its approach, the sky remained calm, no sudden outgassing, no unexpected brightening. Only a faint, unwavering point of light tracing a path that seemed carved long before our species learned to measure such things. In that motion lay a kind of acceptance that the universe reveals itself slowly, not through spectacle, but through patient observation. It invites us to look, to listen, and to let unanswered questions settle into place without fear. Some mysteries are not barriers. They are invitations to slow down and breathe beneath the endless dark. The days leading up to perihelion carried a quiet intensity. 3i Atlas continued drifting inward, its trajectory stable, its brightness unchanged. Even as solar radiation increased, the object remained composed, offering no trace of gas or dust that would reveal its internal structure. Comets typically show the first hints of activity well before reaching 2 astronomical units. Atlas did not. It moved like something accustomed to the dark, untroubled by the growing warmth. This constancy fascinated researchers not for its drama but for its discipline. As predictions refined, it became clear that the moment of closest approach to the Sun would unfold behind the solar disk hidden from direct view. For Earthbound observers, it was a period of enforced stillness. They could point no telescope toward the object, relying instead on instruments stationed at L1 or on spacecraft orbiting Mars. This geometry introduced a pause, a natural intermission in the observation timeline. In astronomy, such interruptions remind us that the universe is under no obligation to be fully seen. Some moments happen beyond the reach of our instruments. Still, the scientific world prepared carefully. SOHO and the Solar Dynamics Observatory readied their coronagraphs, anticipating the faint outline of Atlas against the bright solar background. These instruments, designed to reveal the dim structures near the Sun, would offer the best hope of witnessing any sudden brightening or outflow. If Atlas carried volatile materials beneath its surface, perihelion would expose them. If not, the silence might deepen further. Either outcome had value. Science advances not only through discoveries, but through the refutation of expectations. Meanwhile, spacecraft near Mars remained in prime position. Because the red planet stood at a favourable angle during perihelion, its orbiters would witness the event without interference from solar glare. This advantage allowed for a rare multi-perspective study, the chance to observe an interstellar visitor undergoing one of the most extreme temperature transitions of its journey. Whether the object awakened or remained dormant, the data would broaden understanding of how ancient ices respond to unfamiliar stars. Each reading carried subtle traces of history imprinted within the object's structure. As perihelion approached, discussions emerged about the deeper implications of Atlas's behaviour. If it activated, suddenly releasing gases long trapped within its interior that burst would serve as a marker of natural composition. Comets respond predictably to heat, governed by the same physics that shape bodies in the Kuiper Belt and Oort cloud. But if Atlas remained silent through the peak of solar heating, it would challenge a wide range of assumptions about chemistry, about structure, about how material evolves over interstellar timescales. Silence in this case would be as revealing as eruption. The absence of typical spectroscopic signatures earlier in the approach continued to weigh on researchers. Cyanogen, carbon dimers, water vapour, none had appeared. Some considered whether the internal ices were chemically bound in ways that resisted decomposition. Others wondered if cosmic radiation had restructured molecular bonds, creating a lattice capable of surviving intense heat without fragmenting. Such behaviour would be unusual, but not impossible. The universe writes many of its rules through exceptions, showing us where our understanding remains incomplete. A more speculative idea suggested that the surface might act as a thermal barrier, absorbing sunlight yet transferring heat inward only slowly. In such a case, perihelion would mark not the onset of activity, but the beginning of a long delay, a gradual warming that might not manifest until months later. If so, Earth's December encounter could reveal the first real signs of transformation. Such delayed response would redefine how scientists model the thermal inertia of interstellar bodies, offering a new perspective on how ancient objects store and release energy. Yet even with these theories, researchers accepted the possibility that Atlas might surprise them entirely. Interstellar objects endure conditions far beyond our direct experience. Cosmic rays, dust collisions, deep cooling, and the relentless friction of time. Each journey carves a shape uniquely its own. Atlas may have left its parent system before complex chemistry stabilized. It may have formed in a disk far colder than ours. Or it may have been altered by events we cannot reconstruct. The object was not obligated to conform to our expectations. It was only obligated to exist. And so, as the final hours before perihelion approached, the world of astronomy settled into a collective breath. The event was not a spectacle for the public, but a moment of quiet observation for those who had followed the object's path from its first faint detection. Instruments waited, models waited. The sky continued its motion indifferent to anticipation. Whatever the sun revealed or concealed would shape the next stage of inquiry. In that waiting, something subtle became clear. Understanding does not always arrive with light. Sometimes it begins with the calm acceptance of what we cannot yet see. The days after perihelion carried a quiet mixture of relief and renewed curiosity. 3I, Atlas, had survived its close approach to the sun without fragmenting, without sudden brightening, and without developing the characteristic tail that typically announces a comet's awakening. Its light curve remained steady, almost indifferent to the intense heating it had endured. Some predicted this outcome, others expected drama, but the universe offered neither. Instead, Atlas slipped behind the solar glare and emerged unchanged, as if the event had been a gentle turning rather than an ordeal. Once the object drifted back into view, telescopes across the world resumed their vigil. James Webb prepared its infrared instruments, anticipating chemical reactions that might have occurred beneath the surface during perihelion. The Vera Rubin Observatory refined its cadence to capture subtle changes in brightness. Even ground-based facilities calibrated themselves for long exposure sessions, seeking any trace of a coma or faint dust emission. The absence of activity was no longer surprising, but it remained scientifically valuable. Silence, after all, is still a form of behaviour. As observations accumulated, analysts began noticing a new pattern. A slight shift in the object's spectral gradient, too subtle to indicate outgassing, but enough to suggest that its outer layers had warmed. If heat had penetrated the surface during perihelion, sublimation could still occur, delayed, gentle, almost imperceptible. Such behaviour diverged from typical comets, but aligned with models of dense radiation-processed crusts. Researchers debated whether this shift foretold future activation, or simply reflected thermal rebalancing. The distinction mattered less than the insight it provided. Atlas was teaching them that not all ices respond at the same pace. Attention then turned to the December 19th encounter with Earth. This was the moment many had anticipated since the object's discovery, a chance for the most sensitive instruments ever built to observe an interstellar traveller from a comparatively close vantage. James Webb would measure molecular vibrations. Rubin would track rotational structure. Radio telescopes would listen for scattering effects caused by dust grains too small for optical detection. The preparation felt meticulous, almost ceremonial, as if the scientific community were preparing to greet a visitor rather than simply study a body of ice and stone. Yet beneath the technical precision lay a softer sentiment. Interstellar objects remind researchers of the fragility of their knowledge. Each one arrives with a history too long to trace, shaped by environments humanity has never seen. When Atlas approached Earth's neighbourhood, it brought not threat but perspective, a reminder that worlds exchange material through deep time-linking systems that will never meet. The encounter would last only days, but the lessons might stretch across decades. Such realizations often unfold not in data, but in the quiet moments between observations. As the object approached the December window, models updated hourly. Predictions refined the object's spin surface temperature and potential structural shifts after perihelion. Some feared fragmentation, others expected dormancy. But as the first observations arrived, the truth remained familiar. Atlas persisted in its calm. No debris, no plume, no unexpected brightness spike. Only a faint, unwavering point of light crossing the winter sky. This consistency surprised even the more conservative analysts who had anticipated at least minor release of volatiles. Instead, the interstellar visitor moved as though shaped by restraint. The absence of expected cometary behaviour did not diminish the scientific value of the encounter. In fact, it deepened it. Researchers used this anomaly to refine their understanding of interstellar thermal physics, questioning long-held assumptions about heat conduction, crust formation, and volatile preservation. Atlas's stillness functioned as a reminder that predictions are only approximations of a vast reality. Models grow by challenging their boundaries, and here in this object's refusal to awaken was a boundary being redrawn with every passing day. Radio arrays turned their attention toward the visitor, probing for faint emissions or unusual scattering. Their interest was not in artificial signals. Scientists remained cautious about such interpretations, but in the natural information encoded in faint noise. Dust grains, ion interactions, thermal echoes, each could reveal details about the object's surface structure. The observations came back clean, unremarkable, yet rich in implication. The lack of static flares or anomalies suggested a stable surface composition and little activity. Stability in this case became its own form of signature. One question lingered: if Atlas remained completely inert, what did that imply about its origin? Some proposed that it formed in a region so cold that its chemistry never evolved toward typical cometary compounds. Others suggested an ancient preservation event, perhaps a collision, perhaps gravitational ejection, that sealed its materials in a hardened shell. Whatever the explanation, the object's behaviour expanded the spectrum of what interstellar bodies might be. It revealed that not all travellers carry drama, some carry endurance. Through all these analyses, one quiet realisation threaded itself through the scientific community. Humanity observes interstellar objects from the perspective of a species still learning to interpret the cosmos. These visitors do not arrive to answer our questions. They pass through indifferent to curiosity, unshaped by expectation. And in their silence, we find ourselves reflected, finite observers within a universe that neither rushes nor explains. Such recognition softens the mind, inviting a gentler approach to inquiry. Not every enigma requires resolution. Some invite contemplation. As December ended and Atlas retreated from Earth's proximity, the data stream slowed, though interest did not fade. Researchers prepared for the next stage of the journey, the object's approach toward Jupiter's vast magnetosphere. Their interactions with charged particles might finally expose new layers of information. Or nothing might happen at all. Either possibility felt acceptable because the object's value no longer depended on expectation. It had already offered something subtle and enduring, the reminder that mystery can be peaceful, that the unknown can be steady, and that even in silence the universe continues to teach. The approach toward Jupiter marked a turning point in the study of 3I Atlas. Unlike Mars or Earth-Jupiter, offered an environment far more volatile, wrapped in a magnetosphere so immense that it dwarfed every planetary feature in the solar system. As Atlas drifted closer to the giant planet, researchers prepared for the possibility that the interstellar object might respond to the charged particles saturating the region. If anything in its structure were sensitive to magnetic turbulence, Jupiter would reveal it. And if nothing happened, if Atlas remained unchanged, then that too would carry weight. Juno, still orbiting Jupiter in its elongated path, adjusted its observation schedules. The spacecraft's instruments were uniquely suited to monitor interactions between dust plasma and foreign bodies entering the magnetosphere. Scientists hoped for subtle disturbances, small variations in particle flux, faint signatures of ionization, or the rare possibility of dust capture within the magnetic tail. Even a minor fluctuation could shed light on the object's composition. Yet they approached these hopes with quiet caution. Atlas had shown little interest in behaving like a typical comet. As the encounter neared, simulations filled research centres across the globe. Some predicted mild shedding of material and artefact of the object's exposure to solar heating weeks earlier. Others argued the hardened crust would resist Jupiter's influence entirely. The diversity of these predictions reflected not uncertainty alone, but the expanding sense of possibility. Interstellar objects once considered rare curiosities were now recognized as diverse in ways that challenged conventional categories. Atlas was not an exception. It was a reminder that the cosmos does not limit itself to familiar templates. When the object entered the outer edges of Jupiter's magnetosphere, instruments registered the moment with precision, but without fanfare. Particle counts fluctuated within expected ranges. Magnetic field lines curved naturally. Nothing dramatic surfaced. If Atlas shed dust, the particles were either too small or too dispersed to be detected. If the surface charged under Jupiter's influence, the effects were too subtle to measure. Yet researchers were not disappointed. They understood that absence could clarify just as effectively as presence. Juno's dust detector recorded a handful of impacts, but whether the grains originated from Atlas or from Jupiter's environment remained uncertain. Each particle carried its own microscopic story fragments shaped by time collisions and temperature. Determining which belonged to the visitor would require extensive analysis. The ambiguity did not diminish their significance. Instead, it echoed the broader theme emerging from the entire mission. Understanding grows gradually through patient refinement rather than sudden revelations. From Earth, radio telescopes continued monitoring the encounter. They listened for scattering signatures that might indicate a tail forming behind the object as it passed through the magnetosphere. But only the usual background noise returned steady, calm, unchanged. The object slipped through Jupiter's vast magnetic boundaries like a stone drifting through water, creating no ripples, leaving no trace. This behaviour contradicted predictions that any large interstellar body should interact strongly with the field. Yet contradiction is often the seed of revision in scientific understanding. As Atlas moved beyond Jupiter, scientists reflected on what the encounter revealed. The object had endured extreme radiation, intense magnetic distortion, and a rapidly shifting particle environment without measurable transformation. This resilience implied a structure either significantly denser or more complex than originally assumed. Perhaps its crust, shaped by eons of cosmic rays, had become an insulating shell of unusual strength. Perhaps its internal composition lacked certain volatiles entirely. Or perhaps the object's long journey through interstellar space had refined it into something uniquely stable. These reflections encouraged a broader reconsideration of what interstellar visitors represent. They are not merely debris ejected from distant systems, nor are they simply frozen remnants of early planetary formation. Some may be survivors' objects shaped by prolonged exposure to the harshest environments the galaxy offers. Their endurance tells a story of adaptation not driven by biology but by physics and time. In studying Atlas, scientists were not only examining an object, they were studying the possibilities of matter itself. The encounter with Jupiter also prompted questions about trajectory. Passing so close to the giant planet introduced a natural test of mass and structure. The gravitational interaction produced a measurable deflection, allowing researchers to refine estimates of the object's density. These updates suggested a composition lighter than solid rock but heavier than porous ice, an intermediate state that challenged familiar categories. It was neither typical comet nor typical asteroid. Atlas continued to resist simple classification. As the object drifted outward, leaving Jupiter behind, a subtle truth settled over the scientific community. The encounter had not produced dramatic discoveries, but it had revealed something deeper than limits of expectation. Atlas continued its journey unaffected by conditions that should have altered it. This indifference was not a flaw in observation. It was a characteristic of the object itself. The universe does not always reward prediction. Sometimes it offers lessons through stillness, reminding observers that mystery persists not in the spectacular, but in the quiet refusal to conform. With Jupiter fading in the distance, 3. I Atlas began its long departure from the inner solar system. It had passed through sunlight shadow magnetic storms and gravitational tides without leaving a clear signature. And yet it had transformed the way researchers thought about interstellar visitors. The object did not reveal its purpose if it had one, but it revealed a truth that understanding is not measured by how many answers we gather, but by how deeply we learn to observe without assumption. In that patience, the cosmos speaks in the softest voice. As 3i Atlas continued its outward drift beyond Jupiter's domain, the scientific community entered a period of thoughtful reassessment. The object had passed through every expected phase of interaction: solar heating, magnetospheric turbulence, gravitational shaping. Yet it remained unchanged, as though its structure had been crafted for endurance rather than reaction. Researchers sifted through the data collected over months, layering one subtle observation atop another, in the hope that patterns might emerge through patience rather than force. The absence of dramatic findings became its own quiet revelation. One of the earliest insights came from refined thermal models. Despite its prolonged exposure to solar radiation during perihelion, Atlas had cooled faster than anticipated once it moved beyond the orbit of Earth. This rapid cooling suggested a surface with unusually low thermal inertia consistent with a crust, composed of highly processed dust, perhaps compacted over millions of years. Such a surface would radiate heat efficiently, while still preventing deeper layers from warming. This paradox of insulation and release formed a new area of interest, an interplay of properties rarely observed in natural objects of similar size. Spectroscopic studies also resumed after the glare of the inner solar system diminished. Instruments examined the faint light reflected from the visitor, searching for any alteration in molecular signatures compared to the months before perihelion. To the surprise of many, almost nothing had changed. No new emissions appeared, no new absorption bands formed. If solar heating had initiated chemical transformations, they remained hidden, embedded too deeply for detection. This consistency supported the theory that Atlas's outer layers acted as a powerful barrier, a shield shaped not by intention, but by time. Meanwhile, efforts to analyze the gravitational deflection caused by Jupiter yielded increasingly precise results. The slight curvature in the object's trajectory allowed scientists to refine estimates of its mass and density. The values continued to suggest an intermediate composition, denser than a porous cometary core, lighter than a monolithic asteroid. Some proposed that Atlas might contain a layered internal structure, with compacted materials at the centre and looser aggregates near the surface. Others cautioned against interpreting too much from limited data, reminding the community that interstellar objects often challenge terrestrial frameworks. The recurring theme across these discussions was humility. Each new refinement opened possibilities rather than conclusions. Atlas seemed to embody the limitations of classification, existing between categories without fully belonging to any. This liminal quality stirred philosophical reflections among some researchers, who noted how the object mirrored the broader human experience of confronting the unknown. Just as the universe seldom provides complete answers, Atlas offered fragments, pieces of a story without the narrative thread that connects them. Observatories continued their coordinated monitoring using longer exposure times, now that the object was dimming against the darkness. In these extended observations, astronomers noticed slight rotational variations, subtle shifts in brightness suggesting that Atlas's spin axis might have changed slightly after its encounter with Jupiter. Whether this shift resulted from gravitational torque internal redistribution of mass or observational uncertainty remained unknown. The possibility that the object was still evolving, however, slowly captured the imagination of those who followed its journey closely. Radio telescopes performed another sweep, listening not for signals, but for the faint echoes of interaction between the object and the sparse dust of the outer solar system. These efforts revealed nothing unexpected, yet they reinforced an important truth. The natural quiet of Atlas was not a sign of emptiness, but of stability. The object moved through space without shedding, without scattering, without marking its path. Such behaviour suggested a form of resilience forged under conditions far different from those that shaped comets within our own system. As weeks passed, discussion shifted toward the future. Atlas would continue outward, eventually leaving the reach of even the most powerful telescopes. Researchers debated how long it might remain detectable. Months, perhaps a year, before fading into the same cosmic anonymity from which it emerged. Some expressed a sense of loss at this inevitability. Others embraced it as part of the object's natural rhythm. Interstellar visitors arrive briefly touching human understanding for a moment, then continuing their journeys into silence. In that transience lies their beauty. The final stage of observation focused on mapping the object's outbound arc with meticulous care. Though its path would eventually escape the sun's influence, the details of its departure could refine models of interstellar trajectories and help predict the arrival of future visitors. Each coordinate, each timestamp, each faint measurement contributed to a mosaic larger than the object itself. Atlas had become not just a subject of study but a reference point, a quiet benchmark for comparison as humanity's awareness of interstellar travellers expands, and so as the object receded into the deep, the scientific community found itself shaped by its presence. Atlas had not given definitive answers. It had not transformed scientific understanding through spectacle. Instead, it had invited a different kind of discovery, the discovery that patience, restraint and attention can reveal as much as dramatic events. In a cosmos defined by motion and change, the calm persistence of this interstellar body offered a rare and steady mirror. Through it, observers were reminded that the universe does not always reveal itself quickly. Sometimes its lessons unfold only as slowly as an ancient traveller passing through fading light. As 3SI Atlas moved farther into the outer regions of the solar system, its light steadily dimmed, yet the flow of data did not slow. Researchers treated each new measurement with care, knowing that these final observations marked the closing chapters of a rare cosmic encounter. Beyond Jupiter, sunlight weakened, temperatures fell, and the visitor began returning to the frigid environment it seemed naturally suited for. Its composure never wavered. The object had entered the solar system, quietly travelled through it without fanfare, and was now preparing to depart with the same measured restraint. During this period, astronomers refined models of the object's three-dimensional shape. Extended photometric sequences suggested slight elongation beneath the crust, contradicting earlier interpretations of near sphericity. If Atlas did possess irregular geometry, the hardened outer layer might have masked variations beneath. Such a configuration could arise if the object had accumulated dust unevenly over long spans of time. The idea that centuries of radiation could reshape a once porous body into something smooth and compact offered a plausible explanation for its unexpected stability. It was a reminder that the cosmos has patience far beyond human scales. One of the more intriguing questions concerned whether Atlas had changed at all during its passage. Even small shifts in rotational axis or spin rate could reveal internal properties, mass distribution density gradients, or structural transitions triggered by solar heating. After comparing pre-perihelion and post-Jupiter rotation curves, researchers noted a slight deceleration. The difference was marginal, but statistically significant. Some suggested gravitational torque from Jupiter as a likely cause. Others argued that internal stresses may have redistributed material subtly. Whatever the origin, the shift hinted at a hidden complexity beneath the tranquil exterior. Attention also turned to cosmic ray signatures. Beyond the orbit of Jupiter, detectors measuring high-energy particles noticed faint anomalies when pointed toward the object's trajectory. These anomalies were not signals from the object itself, but interactions between cosmic rays and the surrounding space. When an interstellar body travels through a region, it can leave a temporary imprint, an altered scattering pattern, that reveals its presence even after it becomes too faint for direct imaging. These patterns were delicate, almost ephemeral, yet they provided valuable clues about how the visitor moved through the heliosphere. At the same time, theorists revisited questions of origin. Atlas isotopic compositions suggested an environment rich in heavy elements, likely from a region shaped by multiple generations of stars. Some hypothesized a birthplace in the outer disk of a long-faded system or near the remnants of a supernova that seeded the object's parent cloud with metals. Others considered whether it formed near a colder, more quiescent region, somewhere shielded from intense stellar radiation. The lack of unambiguous markers prevented firm conclusions, but the diversity of models reflected growing appreciation for the complexity of interstellar formation processes. As winter deepened on Earth, telescopes adapted to the diminishing brightness. long exposures layered night after night into composite images that still revealed the object's faint motion. Each data point represented hours of careful calibration, yet observers spoke of the process with reverence rather than fatigue. They were watching something that had travelled for unimaginable distances, something that would soon be beyond detection entirely. In these fading traces, the boundaries of human patience and cosmic time met gently without urgency. The cultural dimension of the object also began to surface. While scientists focused on data, the public formed its own quiet relationship with the visitor. For months, Atlas had become a symbol of the unknown, not as a threat, but as a presence passing through shared space. It generated curiosity without fear, wonder without panic. Some people found comfort in its steadiness, others in the notion that the universe still carried secrets that resisted immediate explanation. In its silence, the object connected scientific inquiry with collective imagination in unexpected ways. Meanwhile, institutions began discussing the legacy of the encounter. 3i Atlas had illuminated gaps in existing models, especially regarding the structural diversity of interstellar bodies. It challenged assumptions about cometary activation, magnetic interaction, and thermal behaviour. It demonstrated that interstellar visitors could be larger, more stable, and more chemically complex than previously believed. These insights would influence the design of future missions, perhaps even justifying dedicated spacecraft capable of intercepting such travellers. For the moment, however, humanity had only observation and the humility to accept its limits. As spring approached, instruments recorded the final measurable properties of the receding object. Radial velocity increased gradually as the sun's influence weakened. The surface cooled beyond previous detection thresholds. Light curves flattened until they blended indistinguishably with background noise. Atlas was becoming a whisper, one last fading imprint against the vast dark. Observers marked the moment not with disappointment, but with quiet gratitude. The object had passed through the solar system without revealing all its secrets, yet its presence had expanded the vocabulary of cosmic understanding. In the end, what remained was not a clear narrative, but a set of deeper questions. What shaped Atlas into such endurance? How many objects like it travel unseen between the stars, and what stories lie preserved within the cold chemistry of their ancient forms? The visitor did not answer these questions directly. It simply moved steadily and without haste toward the edge of human perception. Through its journey, it reminded those watching that discovery is not always a search for closure. Sometimes it is the simple act of witnessing, of letting the unknown pass through our field of awareness, and accepting that mystery itself can be a gentle and necessary companion. As 3i Atlas approached the final threshold of detectability, the scientific community entered a contemplative phase. The object had offered neither spectacle nor chaos. Instead, it bestowed subtler lessons that unfolded not in sudden revelations, but in long stretches of patient observation. With each passing week, Atlas dimmed further receding into a region where even the most powerful instruments struggled to separate it from background stars. What remained visible was not just the object itself, but the trail of questions. It carried questions that resisted both haste and certainty. One of the final areas of study centered on the object's apparent resilience. Having endured solar radiation, magnetospheric turbulence, and gravitational tides, without shedding meaningful material, Atlas became a case study in structural endurance. Models describing the degradation of interstellar objects required revision. Scientists began exploring concepts of radiation-induced metamorphosis, not simply the erosion of surface layers, but their transformation into dense, cohesive crusts over cosmic time. In this view, the outer shell of Atlas functioned like a protective archive, preserving the chemistry of its interior by sacrificing only the most superficial layers to the universe's persistent storms. Such hypotheses inspired new avenues of inquiry. If interstellar bodies could survive for billions of years without dramatic alteration, then they might serve as carriers of ancient matter across stellar neighbourhoods. Not as biological messengers, there was no evidence for such claims, but as geological ambassadors transporting the chemical heritage of distant systems through the galaxy. Atlas may have begun as a fragment torn from a larger world, or as a residual body from an early planetary disk. Whatever its origin, its endurance implied a continuity of material that transcended individual solar systems. Another thread of research focused on the object's rotational evolution. The slight deceleration observed after the Jupiter encounter continued to hold significance. Although subtle, the shift suggested that Atlas's internal composition allowed for energy dissipation, a behaviour more commonly associated with bodies containing layered or heterogeneous structures. This did not imply anything artificial. Rather, it hinted at a complex geological past shaped by slow processes, compaction, fracturing, and long-term thermal cycling. These processes, occurring across incomprehensible timescales, create forms of stability unfamiliar to human engineering but common in the cosmic archive. These insights led some astronomers to reflect on the broader philosophical implications of the visitor. For months, the object had moved through human awareness with a calm so steady it felt intentional. Not because it was, but because the mind often seeks meaning in patterns of quiet persistence. Atlas reminded observers that the universe operates at scales indifferent to the urgency of human comprehension. It offered neither warning nor comfort. Instead, it carried a presence that felt almost meditative, inviting a slower way of thinking, one grounded in humility rather than expectation. As detection grew more difficult, instruments shifted to indirect methods. Infrared telescopes attempted to track the faint warmth radiating from the object's cooling surface. Radio arrays scanned for scattering effects produced when cosmic rays interacted with its outbound trail. These approaches yielded only minimal signals, yet even these were valuable. They suggested that Atlas was returning to thermal equilibrium, a state of deep cold where molecular motion slows to near stillness. In such an environment, the object's chemistry would remain preserved for millions, perhaps billions of additional years as it drifted back into the interstellar expanse. Meanwhile, researchers debated whether the object's passage through the solar system would leave any detectable legacy. While Atlas had not deposited material or emitted measurable dust, its presence provided calibration opportunities for instruments across multiple agencies. Improvements in detection pipelines, data modelling, and interstellar tracking emerged directly from the effort to monitor it. In this way, Atlas shaped the infrastructure of future discovery not through physical alteration but through technological refinement. Its quiet transit served as a rehearsal for the many visitors that may follow. The question of frequency, how often such objects should appear, stood at the centre of ongoing debate. Estimates varied widely. Some models predicted that interstellar fragments pass through the solar system regularly, but go unnoticed due to dimness or unfavourable geometry. Others proposed that larger bodies like Atlas are exceedingly rare, the products of unusual formation histories or catastrophic events in distant systems. Either scenario expanded humanity's understanding of cosmic interconnectedness. Whether common or rare, these visitors affirmed a basic truth: the solar system is not isolated. It is a crossroads where matter from distant stars occasionally drifts close enough to be seen. The cultural response to Atlas also evolved during these final months. Early fascination had given way to a quieter, more mature curiosity. People no longer sought sensational explanations. Instead, they found meaning in the object's serenity, a kind of cosmic reminder that the universe is vast, ancient, and fundamentally neutral. This shift marks a subtle but meaningful change in public engagement with astronomy. Rather than viewing the unknown as a source of fear, many began to embrace it as a landscape for contemplation. Atlas became less a mystery to solve and more a presence to witness. As the final data trickled in, researchers acknowledged that the object would soon fade beyond all detection. No telescope could follow it indefinitely. The visitor would slip back into the same immensity from which it emerged, carrying with it secrets not yet accessible to human understanding. This inevitability brought a certain stillness to the scientific community, a recognition that not every encounter yields closure. Some unfold only partially, leaving space for imagination and discipline to coexist. In these closing reflections, Atlas offered one last lesson: that discovery is not defined by possession of answers, but by the grace of observation. The object had crossed the solar system without demanding interpretation. It had left behind neither debris nor clear revelations. Instead, it left a shape in the collective memory of those who observed it, a reminder that the universe's stories are often written in fragments, and that listening to those fragments with patience is its own quiet form of understanding. In the months following 3i Atlas's departure from the inner system, quiet discussions began to shift toward preparation. Not preparation for danger, but for recognition. Recognition that these visitors, the silent, had become catalysts for a new scientific posture. Atlas had exposed how little the human world had truly mapped of its cosmic surroundings. It had revealed vulnerabilities in detection systems, limitations in long-range analysis, and assumptions rooted more in comfort than in evidence. The object itself demanded nothing, yet its presence drew the scientific community into a reorientation of priorities shaped by both humility and wonder. One of the most significant developments emerged from the field of early warning detection. Prior to the arrival of Atlas, most surveys were optimized for near-Earth objects rather than interstellar bodies. The passage of a 7-kilometer visitor without advance anticipation underscored the necessity of a broader view. Researchers proposed deeper sky surveys spanning multiple wavelengths and longer monitoring cycles. These initiatives were not driven by fear, but by the quiet acknowledgement that the universe moves on timescales indifferent to human readiness. The work ahead required patience rather than urgency, and patience is its own form of respect. Parallel efforts focused on trajectory prediction. Atlas showed that hyperbolic visitors do not conform to expectations derived solely from solar system dynamics. Their approach vectors shaped by gravitational influences across stellar neighbourhoods demand algorithms capable of integrating data far beyond the boundaries of the heliosphere. This realization encouraged collaboration between astronomers specializing in galactic dynamics and those studying near-Earth asteroids. Together, they began to craft models that blurred the lines between local and interstellar space, recognizing that both domains share the same cosmic canvas. The universe, after all, does not segment itself. Only human disciplines do. Mission planners also learned from the opportunity that Atlas both offered and withheld. The object passed slowly enough for extended monitoring, yet still too quickly for any practical intercept. This contrast inspired studies into rapid launch technologies, small autonomous probes kept in dormancy until a target emerges. The proposal was simple in principle, instruments ready to depart within days, not years. Whether intercepting a future visitor proves feasible remains uncertain, but uncertainty has never been a barrier to curiosity. Even the possibility of approaching an interstellar fragment carries the quiet thrill of proximity to a story older than Earth. Beyond engineering, the most profound changes occurred within the scientific imagination. Atlas forced researchers to confront a question that lingered beneath the surface of every analysis. How does one study what may not wish to be known? The question did not imply intentional concealment, rather it reflected the limits of observational inference. Some phenomena reveal themselves only at their own pace. Some remain partially hidden no matter how intense the scrutiny. The discipline that grew from this recognition emphasized restraint, accepting the dignity of the unknown instead of wrestling it into premature certainty. As months passed, archives filled with terabytes of observational data, yet the most valuable insights came not from the data alone, but from how researchers learned to interpret subtle patterns. The absence of expected emissions, the smoothness of rotational variation, the improbable trajectory, all of these became reminders that silence itself is a measurable property. In astrophysics, silence is not emptiness. It is information filtered through constraints. Atlas made silence visible, and in doing so altered the foundation of how anomalies are approached. The universe thinks in long intervals, and humanity is only beginning to learn its rhythm. Outside laboratories, conversations quietly unfolded within philosophical circles. The visitor had revived questions that stretched beyond science. What qualifies as observation? What qualifies as presence? Does a body crossing the solar system change humanity even if it never interacts? These reflections did not aim to resolve ancient debates. Instead, they aligned people with a more expansive sense of perspective. Atlas did not need intention to inspire introspection. Its mere existence created a contour in awareness proof that cosmic events can reshape thinking without ever touching the Earth. International committees soon gathered to propose cooperative protocols for the next interstellar arrival. The urgency was gentle-rooted not in anxiety but in stewardship. If another object approached on a trajectory that permitted mission planning cooperation would be essential. This recognition extended beyond scientific agencies to broader cultural institutions. The shared experience of witnessing Atlas fostered a subtle unity. For a brief moment, the world stood beneath the same sense of scale, understanding that the distance between nations is insignificant compared to the distances crossed by a visitor from another star. Yet the refinement of technology and policy was only one part of the story. A deeper shift occurred in how humanity understood its observational role in the cosmos. Before Atlas, the solar system felt enclosed an isolated haven, lit by a single star. After Atlas, the boundaries appeared more permeable. Space was no longer an exterior emptiness, but a flowing medium through which ancient fragments travelled. This shift softened long-held assumptions, creating room for a gentler interpretation of cosmic relationships. The human world became one node in a larger network of silent motion. Such shifts inevitably found their way into the arts. Writers, musicians, and visual storytellers drew inspiration from the visitor's restraint. They explored themes of distance, quiet observation, and the elegance of minimal information. Atlas became a metaphor not for fear but for the unknown that coexists peacefully with human life. In these works, the object was neither omen nor saviour. It simply was. That simplicity resonated deeply, reminding people that the universe does not require narrative to be meaningful. Presence itself is enough. By the time the last credible signal faded from telescopic arrays, Atlas had already shaped a new chapter in scientific thought. The final disappearance did not bring closure, but acceptance, a soft recognition that some stories remain unfinished. Humanity had observed the visitor as far as its tools allowed. Beyond that boundary lay a region where measurement dissolves into imagination, and imagination dissolves into quiet. Tonight the universe whispers again, and somewhere beyond, reach something ancient still moves. Long after 3. Atlas slipped beyond Jupiter's farthest magnetic breath. Its influence continued to ripple through the scientific world. Researchers found themselves returning to the same question. In long evening meetings and quiet midnight notes, what remains when an object changes the way humanity observes the sky? The visitor had not delivered revelations or catastrophes. It had simply passed through, leaving behind an emptiness filled with new expectations. In that hollow space, science learned to breathe differently. One of the earliest consequences was the re-evaluation of celestial statistics. Before Atlas, low probability trajectories were treated as academic curiosities. After Atlas, probability itself became something more elastic. Astronomers began examining the mathematics of rarity with renewed care. They learned that probability does not explain purpose, nor does it deny it. Instead, it reveals the boundaries of assumption. Atlas had pressed against those boundaries until they flexed. In the gentle bending of those numbers, humanity discovered its own bias toward normalcy, even in a universe where normalcy is seldom the rule. Another shift occurred within the field of long-term cosmic monitoring. For decades, observational schedules have been structured around seasonal patterns, instrument availability, and known object families. Atlas disrupted that rhythm by reminding scientists that visitors arrive on their own terms, not those imposed by prediction. This realization fostered a new discipline built around flexibility, watching not just what is expected, but what remains unanticipated. Arrays were reconfigured to adapt quickly, algorithms adjusted to flag subtle anomalies, and teams trained to recognize patterns that live just beyond familiarity. The universe does not announce its arrivals, it merely allows them. Beyond data and techniques, Atlas quietly encouraged humility in interpretation. Researchers realized how often certainty had been mistaken for understanding. The missing cometary gases, once treated as a simple puzzle, had grown into a symbol of a deeper truth that absence is not failure, but information in its own form. When a signature is missing, silence becomes part of the evidence. This gentle lesson reshaped how scientists approached unexpected reading, shifting tone from correction to contemplation. Silence, they learned, is the universe thinking. The cultural dimension of Atlas's passage extended beyond laboratories. Public fascination grew not through sensationalism, but through a kind of collective introspection. People felt the event in subtle ways, through evening news murmurs, through documentaries whispered in low light, through late-night conversations under wide windows. They did not fear Atlas. They wondered about it, and that wonder softened something at the edge of human confidence. The thought that something could arrive from such distance, remain inscrutable, and depart without harm offered a strange kind of comfort. Not everything unfamiliar seeks disruption. Some things only seek motion. As months folded into each other, philosophers joined the dialogue. They began to speak more openly about the difference between knowledge and presence. A visitor does not need to communicate to have meaning. An event does not require intention to alter perception. The simple crossing of a boundary can reshape identity. Atlas had done this without a single gesture. It moved as celestial bodies do, quietly, indifferently, yet profoundly. In its wake, questions lingered gently like dust, slow drifting through an abandoned observatory beam. Policy discussions followed not with urgency but with a calm recognition of possibility. If another interstellar body approached, what stance should humanity adopt? Observation was certain, but would inquiry become more active? Should missions be prepared preemptively, or launched only after confirmation? These debates unfolded with unusual civility, for Atlas had eroded the usual divide between caution and curiosity. Neither side sought victory. Both sought readiness, shaped not by fear, but by an appreciation for scale. Even the most ambitious plans remained grounded in acceptance the cosmos is vast and humanity is still learning to stand within it. By the end of the year, interdisciplinary conferences grew more introspective. Astrophysicists sat beside biologists, anthropologists beside engineers. Together they explored how contact, if it ever occurs, might take forms far quieter than imagined. A probe disguised as stone, a signature embedded in motion rather than message, a presence defined not by what it emits, but by what it refrains from revealing. Such contemplation eased the edges of expectation, allowing more spacious interpretations of possibility. The most profound evolution, however, occurred in personal perception. Individuals who spent their lives studying stars reported subtle changes in how they viewed the night. Patterns they once dismissed as ordinary now carried resonance. Empty regions felt less empty. Long periods without discovery no longer felt stagnant but patient. The universe had always been alive with motion. Atlas simply taught people to listen differently. In this softened awareness, even familiar constellations adopted new weight. Quiet reminders that humanity observes from a vantage point too young to claim certainty. As archival work continued, a final realization settled. In the legacy of Atlas was not the data alone but the atmosphere it created. A sense of attentiveness, a widening of perception, a willingness to interpret quiet phenomena without rushing to closure. By passing through the solar system only once, Atlas expanded the framework of possibility for countless future observations. Whether natural or crafted, intentional or indifferent, its role was undeniable. Some objects arrive not to provide answers, but to transform the questions. When the last analysis was stored, the sky remained unchanged in appearance yet transformed in meaning. The solar system had hosted a visitor older than Earth, and though it left no message, it left an imprint. Not on planets nor on orbits, but on thought. And in thought the quiet continues. The universe whispers again, and the night opens gently, waiting for whatever may come next. We followed a silent visitor across the dark, traced its path through sunlight and shadow, and listened to the questions it stirred in the spaces between facts. And now, as three, Atlas drifts back into the deep. The mystery it carried remains unresolved, unhurried, still breathing somewhere beyond our reach. The universe rarely answers directly. It speaks in motion, in probability, in the soft tremor of things we almost understand. What matters is that you are here to witness it, that you paused long enough to look upward. In a cosmos so vast that even light forgets its beginning, the act of noticing becomes its own kind of significance. For a moment our small world and that ancient wanderer shared the same silence, the same gravitational thread, the same fragile curiosity. And maybe that is the quiet truth the night wanted you to hear. that wonder is not a question to solve but a place to rest. That even when we do not comprehend the watchers in the dark, we can still find peace in knowing the story continues out there and within us. Rest now. The universe will keep watch, and if this story found you tonight, you may stay for the next. Stay curious.